The next time you press a button and a machine responds instantly, you are not seeing a machine, you are actually seeing a decision. Inside the device, something just sensed, processed, and acted accordingly in milliseconds. Your car deciding when to brake, your inverter deciding when to switch, a life support system deciding when to intervene, all without hesitations, all without you even noticing. None of it is random. There is a hidden brain inside, silent, precise, and always working. That's what we are about to uncover. None of them run apps, none of them have a screen you can scroll, but every single one is making decision, controlling the real world in real time. These are embedded systems, and once you understand them, you will never look at any machines the same way again. An embedded system is a computer, but not like your conventional laptop or computer. It's built inside something else for one specific purpose. Mind it, that one specific purpose. Not multitasking, not running 10 applications, just one job, but it done perfectly. Inside it, there is a microcontroller, the brain. There is a memory to store the instruction and data, an input and outputs, sensor bringing information in, actuator pushing action out. That's it. These three pieces of infrastructure followed everywhere, and this exact structure runs everything from a 50 rupees device to a big Mars rover. So what makes embedded system different? First, they are focused to do one job, one specific job, that is one system, one job. Second, they are all real time. They don't get a bit late. Think, if a braking system responds late, that's not lag, that's not fault of a system, that's a accident. Third, they run without almost no resources. Sometimes just a few kilobytes of memory runs a big entire systems. Fourth, they are insanely reliable. This system runs for years without crashing, without no lags. No restart button, no try again. And fifth, the software and hardware are deeply connected. The code is written for the exact chip. Chips change, the code is changed. Now let's talk about the heart of entire embedded system, that is the microcontroller. This tiny chip is a complete computer in itself. Processor, memory, input, out, clock, all packed into one piece of silicon chip. Unlike your laptop processor, which needs external RAM and storage, a microcontroller is self-contained. Small, cheap, power efficient, but unbelievably powerful. This is what you will actually program as an embedded engineer. The moment you write code, upload it, and see an LED respond, you realize something happening powerful. Your code is no longer just a logic on a screen, it's a controlling reality. Now zoom out. Embedded systems are everywhere, in cars, managing engine, airbags, braking systems, in hospitals, inside pacemakers, and inside monitoring systems, in your home, inside smart meters, appliances, security systems, in factories, running machines non-stop day and night. This is not niche field, this is the backbone of physical world. And here's the part most students miss. If you understand embedded system, you become rare, because now you are not just writing software and you are not just building circuits, you are actually doing both, and you have to be very efficient on both fields. You understand how code interacts with hardware, how timing works, how memory is used, how a signal from a sensor turns into physical actions. You stop being just a programmer, you stop being just a hardware engineer. you become someone who can build complete system. And that's what the real power is. Because in embedded system, your code doesn't just run, it acts, it moves things, it controls machines, it interacts with the real world. The feedback, that direct connections, is something no web app, no simulation, no theory can match. Embedded systems are where software meets physics. And if you want to build the technology of the future, this is the things. This is where you can start. So the next time you see a machine, don't just look at what it does. Ask yourself, what's the embedded system inside it thinking right now? That's where engineering begins. So let's come and let's build it.